Everyone, I would like to welcome you all to this webinar where I'll be teaching you to build an end-to-end application with Redis and Langchain. Without further ado, let's go straight down to the agenda of this webinar. All right. So first of all, we will talk about a short history of evolution of ChatGPT, and then we will learn why Langchain is required and what are vector databases and how to utilize Redis as a vector database. I know all these things are buzzwords. You don't have to get overwhelmed. We'll be going into the details about everything that I have written in the agenda, so you don't have to be overwhelmed. So after that, we'll go to the architecture of our chatbot. Then I'll share a demo with you where we will be building an end-to-end application with Redis and Langchain. And after completing our application, we will deploy it on the Streamlit cloud as well. So if that sounds interesting, let's move straight to the business. So first of all, let's talk about a short history of ChatGPT. I know most of you who have joined this session have already been aware of ChatGPT and have been working around with this because it took them only 2 days to reach 1 million users, and it also take them around 2 months to reach to 100 million users. So I hope everyone is aware of that beast. So let's talk about what was the uh, what was the science behind this all thing going on that are called large language models and what it is. So the building blocks for the ChatGPT type of models are the transformers. It was first built by Google in 2017, and and this model was a neural network architecture which was designed to understand natural language in context and produce accurate and useful responses. In our case, as humans, we collect the information in sequences and encode the context of that language, and then we would be able to reciprocate with the other human beings. So this is how language models work similarly. They get the context of the text we are providing them, and they encode it, and they provide a valuable feedback to that. So, okay, so let's suppose we have a large corpus of data like Wikipedia, that is just a general knowledge. So we have this language model and we have feed the general knowledge data into it. Then what we do the fine tuning of the model. That most of the prompts you have seen, like you ask ChatGPT to work as an instructor or a co-pilot or a marketing agent for you. So these are the task specific data set on which the model was fine-tuned. That's why it was previously called as instruct GPT. You were used to ask them that act as an instructor for me, act as a co-pilot for me. So so the model was fine-tuned on this specific data set. And after that, our model is fine-tuned. We test the data. We have a test data set that we check our final model on it. And then we deliver what the world known as ChatGPT. So this was created by OpenAI, and Transformer was the backbone of this particular beast. So now moving forward to why LangChain is required. And first of all, what is LangChain? Before delving into the intricacies of LangChain, let's suppose we have a case study. You are this particular user and you have published your own paper that is not on the internet yet. So if you ask any question that is general knowledge related to ChatGPT, it would be able to answer it. But what if your data is not on the internet? Your data is either in a particular database or you have it, or that is on your PC. So that is where we have an orchestration tool that comes into play. So orchestration tools helps providing the context to ChatGPT, and we will look into the architecture of how these things get done. So take this as like LangChain provides the context with the question to ChatGPT. So these are the orchestration tools which helps ChatGPT to efficiently respond according to your own corpus of data. So let's see the architecture, how LangChain works with ChatGPT. So this is why everyone would ask, why should I use these tools? I have the ChatGPT, and whatever I'm going to ask him, he's going to provide me. So the problem over here is that ChatGPT is trained on only the general knowledge that is available on the internet. So now how we can utilize that particular large language model with our corpus of data? So this is where LangChain comes into play. Now look at the architecture over here. So suppose you are this user and you ask a question, okay, so tell me about a particular paper that you have written and you want to ask questions regarding that particular paper. So let me go to this. So I have this particular paper over here that has been published in 2023. So what if I ask ChatGPT that it is not uploaded on the internet and just tell me the name of the authors and what was the cost of this of training this model? So he won't be able to reply to this because he does not have the context of this paper. So this is where LangChain comes into play. So let's go back to the architecture. So you guys have the clear that you will be asking the question. So now your question will split into two parts. First of all, your question will go to the ChatGPT, but it will wait till the context and relevant information has been collected from this black box. Why I'm calling this black box? Because I'm going to throw a lot of buzzwords over here that you don't have to get overwhelmed because I'll be explaining that in our later conversation. So your question will split into two parts. It will go to the to ChatGPT and it will wait until you provided the relevant info. Now the question arises how we will be able to collect the relevant information from the database. So now a new word comes that we have a vector database and we store all of our data into this vector database. And by the use of similarity search, we collect the relevant info and throw it into the window of ChatGPT. And after that, we have the question and relevant info. It will go straight to the OpenAI API, and it will give you a useful response. So this is how it works. You passed a question, it will go and search into the vector database about the relevant info. And with your question and relevant info, ChatGPT would be able to answer it correctly. So in short, you're providing the context as well as the question to the ChatGPT, and then he would be able to answer your problem concisely. So moving towards what is the science behind this vector database? What is similarity search? So I would like to clear all of these things and all of these buzzwords in a while. All right. So before going into the depth of vector databases, we have vector embeddings. Now the question arises, what are vector embeddings? So let's suppose you have three sentences. Today is a sunny day. This is a happy dog. That is a very happy person. So what embedding models do, they convert those corpus of sentences, those corpus of data into vector representation. So this is just nothing, just a array of numbers. So these are the vector representation of this particular sentence. So I have converted this sentence into an array of numbers. So these are just vector embeddings. So we store these vector embeddings into the vector database. So let's move forward. This is how it looks into the vector space. So if I have these three sentences, today is a sunny day, it is lying over here. That is a happy dog, it is lying over here. That is a very happy person, it is lying over here. So now when the user will ask this question, that is a happy person. So this is our query. As I have told you before, that your question will go into the vector database and as well as into the window of ChatGPT. So what your question will be doing over here, it will be doing the vector similarity search. And how does that thing work? So this is your particular question. That is a happy person. So how vector similarity search works? It works in the similar way that we have studied in our 10th grade mathematics of vector representation, that the difference between two vectors is the angle between them. So the vector database will calculate the cosine similarity between two vectors, and it will provide the similarity results. So my question was, that is a happy person. It was 94% similar to this particular question. That is a very happy person. So you can see there is a 94% similarity between this. So this is how it works. The vector similarity search is just calculating the angles between two similar vectors and giving us the most relevant information. So let's go back to the architecture. I have asked, that is a very happy person. So it will go into the vector database and it will get the relevant information from there and provide me the output. So this is how the things works. And this is the science behind vector similarity search. So now look at this at a very higher level. So we have our vector databases. So first of all, we get our unstructured data, that is images, text, audio, or any video file. So we convert those unstructured data, that is either text or anything, we convert them into vector embeddings using an embedding model that are provided by Hugging Face, OpenAI, and Cohere. So our unstructured data is converted into vector embeddings, and then we store those embeddings into vector database. So this is how vector embeddings are stored in the vector database. And we apply cosine similarity search over here, which is just the difference between two vectors and the angle between them, which provides us the similar results and relevant info. So we have to install some prerequisites. So first of all, to get the code of this repo, you have to go to this account, that is GitHub, and you will have to clone this repo. So in order to that, you should have a Docker desktop installed, and this is how it looks. So before doing that, let's just clone this repo. All right, so I'm just gonna git bash over here, and I'm just gonna clone my repo, git clone, and I'm gonna paste the link over here. All right, so we have cloned our chatbot over here, and now we can open it with the VS Code as well. So another dependency for this is to install the Docker desktop, and you can install the Docker desktop by on the Windows. So let's see. So you just the first file will come up and you have to just install it. That's how it looks like. And after installing the Docker desktop, you have to run this particular command, docker run. It will install the Redis database image on your PC. So you have to just put this in your command prompt, and it will install the Docker image on your PC. So this is how it looks like. So I have already done the prerequisites. I have installed my Docker desktop. I have cloned the repo, and my Redis image is up and running on port 6379. So you see my Redis vector database is up and running. So if you want to just see that if it's working, you can just write ping and it will respond to you. So you have to connect with Redis CLI as well. And you just have to write ping and it will answer yes form. So this means our Redis vector database is up and running. All right. So after cloning the repo, you have to follow some of the mentioned steps in the README file, and you would be able to run this app locally. So now we have to build this app on our own. For that very reason, I have this command over here. Okay, so before doing that, you should also have a open API key as well. Okay, so that is to be stored in the .env file. So you would be able to store your OpenAI key in the .env file. And now we have to build the end-to-end application. So before doing that, we have to import some of, all right, so the requirements of this are already in the repo. So we have to import Streamlit. So Streamlit is just a Python library that is used to build web applications. So we're going to import Streamlit as st. All right, so let's run this. So my terminal is already up and running. Let me create a new version of it. All right. So before doing that, we have to define our main function. All right, this would be our main function, and you don't have to get overwhelmed. We have to just write 20 lines of code and our application would be up and running. So before doing this, we have to create an initializer that whenever we run this file, it will run this main function for us. So I'm just initializing it using main. This is a simple if statement that whenever I'll run this file, run the main function for me. All right, so let's run this. Okay, so let's run this file streamlit run app.py, and this will be start running on your local host. Let's wait for this. Okay, so we have our streamlit that is up and running. All right, so it is showing some of the errors just because we haven't initialized anything else. So let's start writing into our main function. Okay, so first of all, we should have a header. So I'm calling streamlit as st and st.header, and we can write with some like anything that you would like to add as in header, that chat with your PDF, and I'm gonna control save and rerun it, and the header will appear over here. So before that, we also want a sidebar with the documentations of Streamlit, Langchain, and OpenAI. That would look great because ChatGPT also has a sidebar over here. So let's create a sidebar for us as well. We're gonna write with st.sidebar, and now we have to give it a title as well. st.title. This could be anything. So let's copy some of the emojis from here. Yeah, to run this application, we do need to have an OpenAI API key. So we can do this with an open source LLM resources as well. That would be another topic for another webinar. We can do completely with an open source LLMs as well. So you can get the Open API key by just joining their subscription, and you have to this cost you around few dollars. So you have to put the information of your billings and debit card. So you would be able to get your Open API key. So yeah, I have stored that in my env file. So let's write some text as well. All right, so after running this, you see our sidebar will appear. So this is the title of the sidebar. Let's link down some of the resources, st.markdown. And let me just copy some of the links to the resources. Copy and paste. Okay, so we have to rerun this file again. All right, so we got the documentations for Streamlit that I have already told you before. It is just a Python library to build applications on the front end. So we have Langchain, that is our orchestration tool that we are using to provide context to the ChatGPT window, and we have OpenAI. All right, so let's close the sidebar and start working on our application. So first of all, what do we need first? As if we want to chat with your PDF, so you should have a PDF uploader. So for that very reason, we have to we can Streamlit provide us with a file uploader that is we're going to store it into a variable that is PDF is equals to st.file uploader, and we can write over here that upload your PDF, comma, and we're going to specify the type of the files that we are uploading over here. Type is equals to PDF. And we're going to control save it and rerun our application. All right. So we have our file uploader over here. So now let's go to the architecture, what we are trying to build. Okay, we don't have to worry about all of this because we are going to cover it one by one. Let's go to the step one. Okay, so the step one would be we have to upload our PDF and convert it into chunks of documents so that we can create embeddings. So let me give an overview of this. We have to upload our PDF, convert them into chunks, store them in the vector database as embeddings, and then what it will do, we have a chain. So we will write a question, it will convert, it will extract the relevant info, and it will put that relevant info, that is your context from documents and question, and send it to ChatGPT. So I'm going to repeat this chain again, that we will write this question, and after collecting the relevant information, we would be able to complete this chain, and we are going to send it to the ChatGPT API to provide us a useful response. All right, so let's go to the first part. We have uploaded our PDF. Now the major part is to divide it into chunks. So let's write the code for that as well. Okay, so now we have our PDF over here, but we have to read the text from the PDF as well. So for reading the text from the PDF, we have another package from Python, that is PyPDF, PyPDF2. We're gonna import PDF reader. So here it is. So we have imported the PDF reader over here. So now we can call it as PDF reader is equals to and we're going to pass the PDF into it. All right. So let's see. st.write is basically a print function that we use in Python. So it will just print out the result on the front end. So PDF reader. All right, control save it and rerun the application. Okay, so all right, we have an error. This says that it cannot read the file that has the data type of none. That is because we haven't uploaded a file yet. Let's upload something. After uploading, you see it has read this particular file and stored the object at this particular index. So basically, if we get st.write and I say PDF, if we do not upload anything, control save it, rerun the application, cross it. If we do not upload anything, it will say none. That is, it cannot read the data type of none. So we have to write a particular code over here that if PDF is not none, then you will run this block of code. And now I'm going to indent it over here. So the error will disappear. Okay, let's rerun this application, and you see this block of code will only run if the PDF is not none. So let's remove these things because they are just our print functions for using Streamlit. Okay, so now we have uploaded our PDF and we have read the PDF. Now we have to convert that particular text into chunks. So let's break down that text into chunks. So let's create a variable text is equals to an array, and then we can, now let's see what I'm trying to do over here. Let's suppose I have uploaded this particular PDF. So I have to read all of the text over here and convert it into embeddings. So I'm going to do that by going through this PDF page by page. So I have to iterate through all of the pages and convert them into chunks. So you can see over here that I have, let's suppose I have 200 pages. So I have to make chunks according to the size and the context window. So I'm just doing that by utilizing a for loop over here. Let's open this up for again and Streamlit app as well. So let's read this PDF one by one through page by page. All right, so I'm gonna write for page in PDF reader dot pages. All right, so now we are going to extract chunks is equals to page dot extract text, and we are going to say text dot append content. Let's see what I have done it over here, st.write, and let's see text. So let's rerun this application again. So after uploading our PDF, okay, so we're going to say chunks. Let's rerun this again. Okay, so what I have done, I have uploaded my PDF and read the text from it and convert it into particular chunks. As you can see over here, this is our first chunk. This is the second one. So we can close this third. All right, so we have those 3 pages over here. So now we can commit this particular thing. So let's go back to the architecture again over here. So we have uploaded our PDF, read the text from it, convert it into chunks, and now let's create embeddings. So for that very reason, we have to call, first of all, I have to load the .env I have created, .env. And let's import from .env. .env import code.env. Okay, so we got our env file, and so Langchain provide us the embeddings function, that is Langchain dot embeddings dot OpenAI import OpenAI embeddings. Okay, so we are calling OpenAI embeddings from Langchain to create embeddings of our text. So let's create that as well. So we're going to call embeddings is equals to OpenAI embeddings. So this will create the embeddings for our text. Now let's go back to the architecture as well. We have converted into a text, create the embeddings. Now we have to create the vector database. So for that, we have to import from Langchain dot vector stores dot redis import Redis. Okay, so we have imported our vector database as well. Let's create vector store over here. Vector store redis dot from text. We're gonna pass the text we have compiled. Text is equals to text comma redis comma. Now we have to pass this Redis URL that is required. So that would be the local host and the port we are running the Redis on. So let's give it to this particular function, the Redis URL. So this is just Redis semicolon local host, and the port we are running our Redis image on it, 6379. So as you can see over here, our Redis is running on this particular port. So you have to provide the local host and the port you are running. So this would be your Redis URL. Okay, so we are good to go now. All right, so we have uploaded our PDF, collected the text from it, created the embeddings, and created the vector store. Now all we have to do is to give the query input. So the user can input the query text input. So we can call it as ask questions related to PDF. I'm gonna save it and rerun it. All right. So see, we have uploaded our PDF, read that particular PDF, and we are good to ask the questions from it. Now the last thing that is left is to create this particular chain where I will be asking the question, it will extract the relevant info, and it will provide to ChatGPT. So to create this particular chain, I'm gonna import a bunch of libraries from Langchain again, from Langchain. LLMs. I'm gonna import OpenAI, and I have to also import the chaining part as well. So Langchain dot chains dot question answering import load QA chain. So this is it. We are almost done with our application. So we have to just write a few lines of code more. So we have asked the query as well. Okay, let's have a better look over here. So now the last thing that is left is to say if there is the query, you should do this particular task for me. You're gonna get the results from vector store and we are going to do the similarity search. And if anyone of you has joined late, so I have already explained what is similarity search. You will be provided the recordings, so you can go over the recordings and look over the theory part, and you will understand what is this similarity search. So I'm going to pass query is equals to query, and it also gives us this particular parameter, that is k. We can write it as 2 or 3. That is the number of contexts and documents it will extract from the vector database. So let's suppose if you have 200 pages, so it will extract 3 pages or three chunks of the context that is most relevant to your data. All right. So let's write LLM is equals to, we're gonna call open AI over here, and we're gonna say, right. So after doing this, we can create a chain that is load QA chain, and we're gonna pass two things over here. LLM is equals to LLM and chain type. So chain type is basically a bit technical word over here. We have map reduce, we have stuff. So I'm going to go with the basic one, that is stuff. And let's not delve into the intricacies of that because I don't want to make this more complicated. We have already written a good amount of code. So let's just see the response. Get the response from OpenAI and store it. We're going to chain dot run. So it will get the input documents from us. Documents. So we are providing the result as the input documents and the question as the query. All right, so this is it. We have completed our application, just writing the response from it. And now you can see, okay, so we are good to go now. Let's open this and start this. Let's rerun this application. All right, so I'm gonna browse again and upload my PDF over here. It's gonna create the embeddings for us, and I can ask who are the authors of this paper. And it is running right now, and it will provide us the answer. The author of this paper are Yuvanesh, Anand, Zach, Brandon, Benjamin. Let's revisit our paper. So see, it has provided the correct names of the authors of the paper we have uploaded. Let's ask a bit of tricky question from him that I have written over here. That what was the cost for training GPT-4 model? Let's control and paste it over here. Let's ask this. Okay, so it has got the cost that is 500, all right, and 800. So it has converted into embeddings, and it got the cost from this particular section. So see how powerful this tool is. We have converted it embeddings, and we got our answers from it. Let's look at the architecture again. I hope this is clear for everyone. We have uploaded our file, converted into chunks, stored it into a vector database as embeddings, and then we created this particular chain where I will be asking the question, it will get me the relevant info, and it will get the question and relevant info and store and send it to ChatGPT API. So this is how we will get the answer from the docs. So this is it, and our application is up and running. You can also deploy this on the cloud. So with this particular thing, and you have to attach your repository and create a subscription for that as well. So this is it from my side. Let's have a review of the theory as well. So if there is any question, please feel free to ask. All right, so there's this one question, can this be done with free without open AI key? Yes, this can be done. We have a lot of open source LLMs that are on Hugging Face, and Cohere also provided a free subscription. So yeah, this can be done. Okay, so here's this question, how do you hide your API? So I have stored it in the .env, and please make sure don't expose your API key. That will like cost you a good amount of dollars. Okay, so yes, this is for a particular PDF file, because I have mentioned it that we are doing for the PDF file. You can do it for the TXT file as well, and the list goes on and on. So Langchain has covered all of those things that you can do. So someone is asking, where the question is coming from, where the prompt comes into the picture in the architecture diagram. All right, so here it is. This is the particular question I'm asking from a PDF. Summarize the PDF in 50 words. It's gonna get this and collect the relevant info, and then it will give me the question and context from this document. And this would be the prompt that we will be passing into the ChatGPT API. So the prompt will look like it is providing the context on top, and then it will ask the question. Yes, we can also integrate that with a full-fledged vector database. So Redis is doing great in the vector database space. So yeah, you can just put all your data into the Redis vector database, and you would be able to ask anything from it by using these orchestration tools and creating an end-to-end application. So why there is a need to chunk this document? This is a pretty good question. This is just because of the context window. So as you have already used ChatGPT, that as the token limit exceeded, it will not generate the answer. So every large language model has a token limit. So we have to consider and chunk the documents so we can get the relevant info in chunk size that is not more than 1,000 words. So you can also specify the chunk size as well. Yes, we can add multiple PDFs as well. That is again, I would say, another topic for another webinar. So yeah, we can use instead of Redis, we can use different vector databases. There are multiple vector databases like ChromaDB, we have Fires, and we have Llama Index as well. That is a very good question. Someone has asked how to train your own LLM, and such as how we can use open source LLMs like Llama. We have Falcon, we have Lacuna. So how we can do this? So basically, open source large language models have their own repo. We can clone that repo and run that open source large language model on our computer as well. And Hugging Face also also host those LLMs for us. So you can use Hugging Face for open source LLMs as well. So Pankaj has asked, can we develop the app like if we want to monitor the efficiency of manufacturing plant with Python and machine learning? So yeah, that is possible. We have anomaly detector as well on Microsoft Azure. You can go and look into that as well. So what it does, it takes the real-time data through Azure Cloud, and it also monitor the efficiency of manufacturing plants as well. So yeah, that is possible. And machine learning is a very vast field. It is also doing pretty well in all sort of industries, whether it is a power plant based industries or anything related to technical side. Yes, we can also remove the document embeddings from the vector database once it has been registered. So you can write up. Okay, so if I can open up my CLI for Redis, so you can write ft.clear in. You can clear the cache from Redis because it also store the embeddings in the cache as well. So you can just clear that particular index. So basically in database, what we do, we create indices. The embeddings are stored on that particular index. After you delete that particular index, your embeddings will be deleted as well. Or you can also update those index with new version of embeddings as well. So I draw this particular architecture using this tool that is XCaliDraw. Yes, let me share those slide again. That does the similarity search. Let me bring my slides again and we'll go straight to that particular part. Okay, so in the theory part, is there any other questions? Just do let me know. I can revisit that particular slide and I can explain you that. So someone has asked you can explain if you can explain vector similarity search. Okay, let's do that again. Let me present my screen. So as I was talking about vector embeddings, so I have told before in this webinar that let's suppose you have three sentences. Today is a sunny day. That is a happy dog. That is a very happy person. So you will convert these sentences into vector embeddings, and after that, vector embeddings is stored in the vector space. You can just the LangChain will do the vector similarity search in the Redis. So how these things work? That you asked a query that is a happy person. So vector similarity is just calculating the angle between two vectors, and the most similar one has the least amount of angle. And see, this, that is a happy person was my query, and that is relevant to this particular thing with 94% similarity. So this is how similarity search works. So it has a lot of different in like search as well. You can do the KNN search as well, where you search for the approximate neighbor search as well. So yeah. Can you zoom out and show us the full code? Yeah, I have also shared the link of my GitHub repo. You can revisit that repo and get the complete code from it. So I have shared that into the comment box. I'm looking, did you have a Docker or any other container? Yes, your Redis image should be running on the Docker so that you can you can have a connection with it as well. So yeah, my Docker desktop is running, and you can see my Redis terminal is up and running over here. So yes, Redis image is deployed on Docker desktop. Okay, so Eric has asked that Redis is missing from the requirements txt. So basically, Eric, we have to install Redis as a dependency. I have told you before that we have to install Docker desktop first, then create Redis database using the image, using the Docker image. So we don't have to install it with Python. Arushi is asking, can you zoom out and show us the full code? Yeah, sure. I can do that for you. I have also shared the particular repo of this, and let me change the preference of the theme as well. So there it is. This is the complete code. It is not more than 20 lines. And this is just the link to the repositories. You don't have to mention it. So this is just this 20 lines that are doing the work for us. All right, here's the complete code. It is uploaded on the GitHub repo as well that I have shared over here. So you will get all those resources, and you can complete this demo by following this README file. You just have to clone this repo, then cd, repo name, pip install requirements, and you have to obtain your OpenAPI key as well. And there's this architecture as well. Thank you so much, everyone. Have a good day.